Okay, guys, good morning. So here's a solution of the previous example I gave you last time, but we actually did not proceed with the computation for the requirement on letter C, D, E, and F. Okay, so today I will be giving you a complete solution of the example problem. So the given problem is actually a rectangular beam, and we are asked to solve uh, first the spacing of the stirrups at the critical section. So for the given values of the beam material properties and dimension, so we have here enumerated the steel area, the material properties for F prime C, Fy, and Fe, the dimensional variables D, D prime, BW, the load, the WU, which is already the factored uniform load in kilonewton per meter, the length of the beam, which is simply supported, and the reduction factor for shear, which is 0.85. So initially we solve for the reaction at maximum shear and draw W of the beam. So for a simply supported beam, the reactions are just very simple to compute, since due to symmetry, we simply multiply WL over 2 and get your reaction at the left and the right support. Okay, so these are both in the unit of kilonewton. So for the maximum shear, the reaction will actually be equivalent to the VU max of your beam, which is equal to 360 also. So let's now proceed with the spacing of the stirrup at the critical section. So the critical section is defined at the distance from the face of the support for a simply supported beam. We then solve for VU, MU, and VC corresponding to a distance x equal to the distance from the left support. So here, the dimension for D is given in the problem to be 540 millimeter, in which we try to convert now your uh, unit of millimeter to meter by simply dividing D by 1000. This is to give consistency in the units we will be arriving at on our computation for VU, MU, and VC. Okay, for your VUD or the VU at the distance, we simply make use of the formula R1 minus WUD to give you a value of 295.2 kilonewton. This was obtained from the formula VU at any distance x is equal to R1 minus WU multiplied by the distance x. Unfortunately, this formula is only good for simply supported beams with uniform loads. Okay, at the entire span. Okay, for your MUD requirement, the area of the shear diagram will actually give you the moment at location D distance. Please bear in mind that the shear and moment diagram was actually a graph on our previous lecture, so we just look into the shear and moment diagram to get uh, the formula for MUD. Okay, so the formula for the moment is simply the area under the shear diagram, which is a trapezoid. Okay, so this is simply the area of a trapezoidal diagram. You can refer to the shear and moment diagram on our previous video. So this is 1/2 VU max plus VU at the D distance multiplied by the distance from the support to the critical section, which is D. And we obtain a value of 176.904 kilonewton meter. So we can now apply the formula VC, which is a detailed formula by the NSCP or the ACI. So the detailed formula is VC is equal to 1/7 square root of FC prime plus 120 rho W VUD at D distance all over MUD multiplied by BWD. So substituting the values of 295.2 and 176.904 in this formula, in this part here, and realizing that F prime C, rho W, and D are given values in the problem, we obtain now a value of 222.958 kilonewton for your VC. So the unit here is only in kilonewton. So next, we solve for the VS. So this is actually the excess shear carried by the stirrups. So the total shear is always carried by the concrete, and a part will be carried by the stirrups. So for your design criteria, your PBN is simply equal to VU. So this is actually the least criteria you can have for a safe design. Okay, so this is a criteria you need for a safe design. So taking note that Vn here can be solved using VU over phi, where Vn is equal to the contribution of your concrete and the contribution of your steel. So substituting back the value of Vn here, we can arrive with the formula for Vs in terms of Vu at D distance all over phi minus Vc, and computing it, you get your value to be 124.336 kilonewton. So we are going now to use that Vs to solve for the spacing of the stirrup using a 10 mm diameter bar, which is a 2-leg bar. The spacing is therefore calculated on the basis of this formula. So the stirrup here may be a closed stirrup or an open stirrup, depending upon the purpose of providing seismic stability or for ordinary beams. Okay, so this is for a seismic design requirement, and this is for ordinary requirement. But still, the legs are computed on the basis of the vertical legs. Okay, so this is actually a two-leg stirrup because the vertical contribution of the stirrup is measured on these two sides here. So AV is computed by simply getting the area of a circle with a diameter of 10 and multiplying it by 2, since this is a two-leg stirrup. So for your S requirement, the spacing is computed by the formula AVFYD all over VS, which is 188.289, rounded down to the nearest 12.5 millimeter or 1 inch. Okay, so this is rounded down to nearest 12.5 millimeter or 1/2 inch. So for the spacing of the stirrup at 1 meter from the face of the support, this is actually another critical section which is secondary to what the critical section definition was provided for in our NSCP code. So the spacing of stirrup at 1.0 meter can be solved using the same procedure. So first we solve for VU, MU, and VC corresponding to the X distance, which is 1 meter from the left support. So take note that D is already in meter this time, as was used on the previous step. And solving for VU at 1 meter, so the formula is the same, R1 minus WUX where X is equal to 1 is equal to 240 kilonewton. So for the moment, again, we simply get the area of the trapezoid, which is 1/2 of the sum of VU max plus VU at 1 meter multiplied by the distance from the left support, which is 1 meter, obtaining a value of 300 kilonewton meter. So for the VC requirement again, so this part here is the one that changes, and simply substituting 240 all over 300 here, we obtain the contribution of concrete in terms of shear strength, which is 178.729 kilonewton. So the unit is only in kilonewton. So solving for VS again, using the same procedure, we check for the value of VS in terms of VU1 over P minus VC. So this is 103.624 kilonewton. So take note that VS is actually decreasing because your shear requirement from left to the center is actually decreasing linearly. So using again a 10 millimeter diameter two-legged bar, the spacing S is therefore calculated on the basis of the formula S AVFYD all over VS. So substituting the new value of VS here, so we have obtained 225.924 as your spacing requirement, rounding it down to the nearest 12.5 millimeter or 1/2 inch. So we can say that the spacing is good for, say, 212 millimeter. So that constitutes your first two requirements on the spacing of the stirrup at D distance and the spacing of stirrup at 1 meter from the face of the support. So in the succeeding video, I will be discussing to you uh, the computation or calculation of the location x at which the stirrup is no longer required, and the location x at which AV minimum is required. Okay, so that's all for now, guys. I'll see you on the next video.